Okay, so we're doing the last part of 10.8, which is called conditional probability. This all belongs to homework 10. It's part of the stuff for test number 3. So don't worry about it for test number 2, but we're making the video available. So here we go. All that stuff from 10.8 is test number 3. So first, what I need to do is get my paper down a little bit. Bring my paper just down a little bit. Okay, not too far down, just a little bit. All right, next I need to take hold of the pencil. And now I'm ready to go. Here is the title. It is called Conditional Probability. Okay, so now let's explain this a little bit. Let's first explain. The formula. The probability of A given B, give us a chance to explain, is equal to the probability of A and B over the probability of B. Okay, now this means that little slash there, the slash, this means this is what this means. What's the probability of A of event A occurring given that's the slash. The slash is trying to say given that we know event B, the second one, event B has occurred. There we go. Okay, so let me show you a problem. Here's the experiment. Two dice are tossed. On table. What's the probability? What's the probability what's the probability of getting that the sum is equal to 5, given that we know that one of the dice is equal is equal to 1. Given that we know, it's like given that we know, is like insider info. Okay, so how do we go about this? So here's how we're going to need to get started. Let's get an event A and an event B. The event A is as follows: that the sum is 5. Event B, right? 2 dice are tossed on the table. What's the probability that the sum is 5? That's going to be event A. Sum is 5. And event B is that we know that one of the dice is equal to 1. So event B is one die is equal to 1. Okay, let me move my paper up a little bit. Here we go. Let's get it up a little bit. Very good. Now, here's how we're going to have to calculate this. Let's go through scrap paper, the sample space. The sample space is, let's go through the whole thing. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay. Then 2, 1, etc. 3, 1, etc. 4, 1, etc. 5, 1, etc. And 6, 1, etc. Okay, I still need more space. Let's get this moving up a little bit. Fine. So now, what is the way to put this is, again, using the formula, is the probability of A given B as occurred is equal to the probability of A and B over the probability of B. So what's that equal to? Probability of A and B is that the sum is 5 and the event B of 1 die is equal to 1. So here's some more scrap paper. Sum is 5, right? 5 would be 1, 4, 4, 1, 2, 3, and 3, 2. All right, so what's the probability that the sum is 5, A and B is going to mean that the sum is 5 and also 1 die is 1. Sum is 5 and 1 die is 1. That's going to be these 2 cases only. 1 die is 1 and the sum is 5. There's only 2 out of a 36 chance of that happening. Okay, that's the probability of A and B. What's the probability of B? What does B say? The event day of 1 die is 1. Okay, here's one. That's one case. Second case, third case, fourth case, fifth case, sixth case. Here's a 7th case, because here the 1 is. This is 2, but this is 1. An 8th case, a 9th case, a 10th case, 11th case. That's it. There's no more. No more ones. All right, so how many are there? Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 11 out of 36. So when you have a fraction divided by a fraction, you flip and multiply. So this becomes 2 over 36 times, flip this, 36 over 11. These two cross out, and here's the final answer. 2 over 11 is the final answer to this conditional probability problem. And there we have it. Okay, so that's how you do a conditional probability problem, and that takes care of the material for 10.8, and that's the beginning of the stuff for number 3, for test number 3. You know, it's not on test number 2, but it enables you to do homework number 10. So we stop here.